Thank you.
Yes, and anybody else who's listening, I will fix them. If for some reason yours does not change, that means I just I can't find it. I type in y'all's names into my email to pull up anything that you've sent me. I just type random things like t-test, homework, z-score, assignment, to try and randomly pull up anything that I could think of that would gather these emails. But sometimes I just don't know, it doesn't pop up. So please, 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 if you've sent it to me and you know you've sent it to me, please email me, okay? So today's our last day, guys, and my stupid computer doesn't work. My camera doesn't work. I wish I could see you guys. Look at that. I don't even know where y'all are. And
yeah, that kind of added to it too, because I have a science class. It's the last week of class, and we still have stuff from like February that hasn't been graded yet.
Oh, yeah.
So yeah, that kind of adds to the stress. Like,
to your stress. Okay, well, don't stress on mine. You're fine. You're fine.
Yeah.
I can't pull up your grades and do it right now because I don't want to
No,
show
that's
everybody's.
fine. No.
Yeah, but don't.
Now that I understand, it's all good.
Okay. Okay. So this is our last day, but you know, we still have Thursday and Friday. I don't know if y'all saw the video from yesterday. We're planning on doing like a Friday at 4, this Friday at 4, a little Zoom session. I am going to have a review or kind of like a study guide posted so that we can go through that on Friday. If you can make it, great. If you can't, that's okay. I'll record it and post it. I'm going to try and have your exam open on Saturday. I'm shooting for Saturday. Technically in the syllabus, it says it would be open Monday through Wednesday, but you know, hey, we're in, you know, kind of limbo land here. So if I can get it open and available and you guys can take it on Saturday, it's kind of like, why not, right? So I'm going to try and do that for you guys just so you could get my class out of the way and you can focus on some of these other classes that y'all have. It will only cover chapter 10 and specifically from our 2 sample t-tests going forward, and then chapter 11. Okay. I believe in chapter 10, also I'll add in there effect size, because that's when we talked a little bit about effect size. So that'll be added to your exam. And then, and this beginning stuff of ANOVA, okay? I know it's a lot, and I even had a conversation yesterday afternoon with my dad, and I was telling him that I felt bad because I kept saying it's not hard, and I need to, you know, I trust me, I thought about it. I probably worry about everything too much, and I shouldn't have said that, because the first time seeing this stuff, it is hard. It is overwhelming. It's like, what in the world are we doing? And I don't want to discredit that. Okay. I've looked at this stuff for, you know, 20 years. And so I don't want to dismiss any struggles or your feelings of confusion. I don't want to dismiss that, and I fully understand that. So let's just, I'm just going to kind of go back over it. Let's just go back over this stuff, and so that we can hopefully kind of get it in our head a little bit. Okay. ANOVA is what we call an analysis of variance. And what that means, right? Variance was a measure of variability where we're looking at the differences that exist. Okay. It allows us to compare means, you know, different averages from the different groups. It does allow us to compare the variances or the differences, and it allows us to assess any interactions that may exist. Now, that part, the assessing the interactions, was at the end of the talk yesterday is when I started saying, it can get much more complicated. You can have multiple independent variables. You can have, I think the example that I gave was adults, teens, and kids. And then you could add in there, well, maybe we want to look at male and female. And maybe being male could add like a synergistic effect and maybe just have an overall faster reaction time anyways. And so that's where we could see things like maybe we could assess some sort of interaction between multiple independent variables. We don't do that in this chapter, so you don't have to worry about that. In this chapter, all we are doing is what we call a one-way ANOVA, okay? And it is one independent variable, okay? Just one independent variable. Here it says two or more population means. This is kind of a fancy definition. Really, I'm going to write it right here. One way, you can think of it like this. It's one independent variable, okay? And really, you would use it for three or more. Well, I'm going to say, I was going to type groups, but let's say three or more levels, okay? But we know that if you have levels in your independent variable, essentially that's what creates your groups, right? If we were looking at age is our independent variable, the groups would be the adults, the teens, and the kids. Okay, so those levels are essentially what forms our groups. Okay, so one way ANOVA really is one independent variable, three or more groups, and it allows us to do kind of this stuff. Maybe at this point we could scratch off that part. Okay, but I just want you to know these definitions, be able to, understand that's what ANOVA is, and then one-way ANOVA. When we do ANOVA, we are using the F distribution. Okay, we're using the F distribution, and this is similar to the T distribution, but like we saw yesterday, it gets more complex, right? And just for clarification purposes, this is what I'm talking about when I say the F distribution, okay? Essentially the F table, okay? So it's sort of similar, okay? It's based on how many people you have in your study, or it's factored into it. And then what's factored into it is how many groups you have, okay? So just, it's like a t-test, but because ANOVA is more complex, the table gets more complex, okay? We would use this to find our critical values, right? We would use that table to find our critical values. Okay, this part right here, I confused you guys yesterday with this. This part right here has to do with the F test. Okay, so let me kind of clarify, right? When I talked about the T distribution, that's where we get our critical values from the T table. When we talk about the T, or our T value, we are calculating a T test. Okay, when we would do a T all the way in that step 3, and we would ultimately find out what our T value is. Okay, so this part, this highlighted part here, has to do with when we're calculating an F-test. Okay, so ultimately we find F by dividing our MS treat divided by our MS error. Okay, and you can think of F as a ratio of variances. These right here, this is a variance and this is a variance, okay? If you notice, compared to a t-test, we are not working with standard deviation here, okay? In a t-test, we compared means, right? I'm just going to write it up here, just separate. If you remember, T was the mean of one, group minus the mean of another group, and then we divided it by standard error, but essentially a standard deviation, right? In the F-test, we have more than two groups, so we can't do that. And we're working with a variance instead of standard deviation, okay? So essentially what's happening here is this is a variance and this is a variance. So it's a ratio of variances, okay? Okay, any questions at that part? Okay. So this slide goes into talking about these terms that we use. Well, it's used in statistics a lot, and it technically is, even when we think of like just a t-test, we were using this, we just didn't word it this way. We didn't call it this, okay? But they bring it up here, and I hope that it makes a little more sense. So we're going to talk about the denominator and the numerator of how we calculate F, okay? So F, if you want to think of it like this, is equal to sorry, I don't know what happened. Okay, there we go. The between divided by the within. And I'm going to clarify, right? We're talking about variance. Can't write very well on this one. The variance, okay. So the between variance divided by the within I don't know what I wrote, variance, all right. So what we mean by that is, just like with the t-test, when we had T was equal to the mean of this group minus the mean of that group, this part up here is we are comparing between these two groups, right? Say we were looking at men versus women. We were looking at the average for the men compared to the average for the women. It's almost like we were pitting them against each other. We were looking at the differences between those two groups of individuals, okay? Oops. However, we know that not all women and men are the same, right? So when we would go through and calculate our standard deviation, we were, if you remember way back to chapter 3, and I think it was chapter 3, it might have been chapter 4, but anyways, we took the individual scores, we found the average for that group, and then we subtracted off the average from every single person's individual score. And then we added them up and we squared them, and we came up with these numbers where we found out this is how you differ on average from the mean. We know you're not all the same, but this is how you all are different for the most part. That's what standard deviation is, okay? So even way back at the beginning of this semester, we were taking into consideration everybody's differences. We said, we know men and women are different, but we also know that within the men, within the women, they are different. Not all man's the same and not all women are the same. So we were looking at how are they different within their own groups. So this is what the F-test does. We're trying to figure out the differences between all the different groups that we have. And we're also going to figure out what is the difference within each individual group. Okay. So this is where we get the, it's kind of annoying that these are flip-flop, but that's okay. Excuse me. So within and between. Some books, some authors, this is what they use. You would even see like this. You would see MS within. My classes a couple of years ago, this is what I would write because that's what the author used, MS within and MS between. Okay, so just if you know that these go together, okay, this author uses MS error, the error that exists, that the differences, the variations that exist within the group. And then this one over here, he calls MS treat. And treat is short for treatment. Okay, it's short for the treatment. And if you want to think about it that way, right, treatment was another word that we could use for our levels, right? And we know that that's another level for our groups. So here they're looking at the top part, right? Our groups. I hope that part makes sense, that you get that down. There will be questions like this on the test, okay, within, between, and just kind of being able to know what we're talking about, okay? All right, so we went over these examples yesterday, and I'm going to skip that for now because I went over it, but I want to talk a little bit more about this source table that's here, okay? So a source table is used in ANOVA to, I guess, kind of organize your step 3, you know, when you do all the calculations. And it allows you to kind of organize and then see kind of clearly, hopefully, where these numbers are coming from, okay? So SS, let's just start at the basics here. SS stands for sum of squares. And sum of squares is exactly what it sounds like. You add up all the squares, okay? Remember, essentially, we were doing that when we would do our standard deviation, right? We would square the differences and we would sum them up, right? So this is a variation of that. Obviously, it gets way more complex, okay? And that's what, let's see, let's show. That's what these are here. We have sum of squares total. This one is sum of squares treat. He's just filling in there what the treatments were. In this example, drug A was one treatment, drug B was another treatment, and drug C was the other treatment. Okay, so it's just filling it in there to show you this is the SS between, right? SS between. They're looking at the differences between these different groups. The SS error, we've now learned, is our SS within. Okay, we're looking at all these differences within the groups. Okay, so that's where our SS's are coming from right here: treat, error, and SS total. Okay, we also have degrees of freedom, right? We know now degrees of freedom. Okay, and just because ANOVA is more complicated, we have degrees of freedom treat, degrees of freedom error, and degrees of freedom total. Okay, how we find those is, it was typed up over here. I said I was going to type it up and I just haven't done that yet. But let me show you right here. Here it is. Okay, here's degrees of freedom total, degrees of freedom treat, and degrees of freedom error. Okay. So degrees of freedom total, oops, let me write again. Degrees of freedom total is found by in total minus 1, okay? On here, for some reason, it doesn't list our ins, okay? You would have in for this group. Oops, that's a 4. You would have in for this group, and you would have in for this group, okay? So, and how I know that is just how many people are in group A. There's 4 of them, and there's 4 people in group B, and there's 4 people in group C, okay? So in total, you just add all those up. You add up everybody that's in your study, okay? So degrees of freedom total would be 12 minus 1, and we'd get 11, which is what they have right here, right, in total, or degrees of freedom total. Degrees of freedom treatment, oops, I don't like that. Degrees of freedom treatment has to do with the groups, right? Treatment has to do with the groups. So it is equal to K minus 1. K is new for us. K is the number of groups. And in this example, we have 3. So 3 minus 1, and we get 2, which is right here for degrees of freedom, right? He has drugs, but we know that that one's treat, okay? And then degrees of freedom error is a little bit different, but it's okay. Oops, not in. Degrees of freedom error is found by in total minus K, okay? Degrees of freedom error is in total minus K. So it'd be 12 minus 3 groups, and we'd get 9, which is what they have right here, okay? I don't want to confuse anybody, but there's another way you could do degrees of freedom error, and that's essentially just degrees of freedom for this group plus degrees of freedom for this group plus degrees of freedom for this group, okay? But that's how that's found. Okay, this is an easy formula for that one. Okay, so degrees of freedom is in total minus K. Okay, let's see. We learned yesterday that the source table is kind of fun because you can add up, right? Let's see, we add going down, add this way and this way, okay? So that degrees of freedom treat plus degrees of freedom error will equal degrees of freedom total. And the same for degrees of, or sorry, SS, right? SS treat plus SS error will equal SS total. Degrees of freedom treat plus degrees of freedom error will equal degrees of freedom total, okay? We don't have an MS total, so that doesn't make sense here. And we don't have an F total or anything like that. So it only works for those two, okay? Now, the cool thing also about this table is that going this way, you divide. Okay, let's get a different color here. Going this way, you divide. I kind of liked the green. Okay, so that SS treat divided by degrees of freedom treat will equal MS treat. Okay, so we divide going sideways. SS error divided by degrees of freedom error is going to equal our MS error. Divide going that way, okay? And then, like I had on the very first slide, we have our F, right? And that F is equal to MS treat. It's too big. MS error. Okay, so here, right, we just take our MS treat divided by our MS error, and it will equal our F. Okay, so this side is a little bit different, right? A little bit different. Okay. Any questions over this part?
I don't think so.
Okay. It's going okay?
Yeah.
Okay, good. Okay. This is just a slide that's just showing the SS, how the SS's work together. Okay, so that's the same thing technically for the degrees of freedom too. Okay, you could substitute that picture with degrees of freedom. So, okay. So let's see. So we have our table that I wrote all over now. And in this example, right, they've calculated their F. They said my F is equal to 11.26. So we're looking at this, and they've already completed step 3, right? They've already done all the calculations, and they found their F test. If we wanted to see if an F equal to 11.26 is significant or not, right? Say we wanted to do step 4 and we wanted to make a decision, we need to see if 11.26 is in the rejection region, right? Does it exceed our critical value? And how we do that is we look at the F table, right? Now this is complex, right? This is like a lot of numbers here, and there's a lot going on. But remember, if we panic in statistics, it's kind of nice because it tells you, right? It tells you all of this stuff. So take a deep breath and let's see what it is that this table is telling us, okay? So these are the alpha levels for a 0.05, right? If you want to test it at a 0.05. And it also gives you the 0.01 alpha levels, okay? And the 0.01 is the bold down here, okay? All of these have a bold level, right? Or bold letters. The 0.05 are these lighter face ones, these top numbers in here, okay? And all of these numbers, these are our critical values, okay? So we have to